There has always been a rhythm to the great silent dark. For a century we have pressed our ear to the cosmos listening. We have learned its language not of words but of physics. It is a language of cycles of dependable repeating beats. We hear the steady lighthouse sweep of a pulsar, a collapsed star spinning hundreds of times a second, its radio beam a celestial metronome marking time across millennia. We can trace the graceful orbital waltz of binary stars, a gravitational duet so predictable we can set our atomic clocks by their dance. Even the universe itself has a fundamental hum, the faint residual whisper of its own violent birth, a static hiss that fills every empty corner of the void. This is the cosmos we thought we knew, a place of profound mind-bending scale, governed by laws that, while complex, were ultimately knowable, ultimately sane. We built our understanding of reality upon this foundation of cosmic order. We took comfort in its predictability, in the elegant mathematics that bound the unfathomable chaos into a coherent, majestic symphony. But what if buried deep within that symphony, beneath the familiar refrains of gravity and light, a single impossible note has been playing all along? What if one night, as you listen to the steady, comforting drumbeat of the void, a new rhythm begins? A rhythm that does not belong, a rhythm that makes no sense, a rhythm that changes everything. That night began like 10,000 others at the Arecibo Deep Sky Array. Here, nestled in the quiet valleys of Puerto Rico, a colossal ear lay open to the heavens, a cathedral of steel and wire dedicated to the art of cosmic eavesdropping. The Night Watch team, a small crew of graduate students and seasoned astronomers, were settling in for another long shift, fueled by lukewarm coffee and the quiet passion that drives one to study the stars. Their target was a magnetar designated PSRJ 1700 and 45A 2900, a truly monstrous object near the supermassive black hole at our galaxy's heart. Magnetars are the universe's titans, the hyper-violent cousins of pulsars. They are neutron stars, possessing magnetic fields so powerful they defy comprehension, a quadrillion times stronger than Earth's. These fields are so intense they warp the very fabric of space-time and can buckle the star's crust, unleashing cataclysmic starquakes that blast out energy with more power than our sun releases in 100,000 years. Its pulse, when it came, was expected to be a brute force instrument of nature, a simple punishing spike of radio waves, the raw scream of physics pushed to its absolute limit. The first pulse arrived precisely on schedule, a familiar shout from 26,000 light-years away. The data streamed onto the monitors, a jagged line against a backdrop of noise. Then came the second pulse, a few seconds later, and a third. Everything was normal. The universe was behaving as it should. And then it wasn't. It started subtly, a flicker in the data that could have been anything. A glitch in a server, a stray signal from a passing aircraft. Atmospheric distortion. The senior astronomer on duty, Dr. Aris Thorne, leaned closer to his screen, his brow furrowed. The pulse, the raw, chaotic blast of energy from the magnetar, should have been a single violent event, followed by a period of relative quiet. Instead, nested within the tail end of the main pulse, like an echo that arrived too soon, was something else, a delicate, impossibly fine structure. It was not noise. Noise is random, chaotic, a meaningless spray of static. This was different. This had shape. It had architecture. He ran a diagnostic, filtering the signal, stripping away the overwhelming roar of the magnetar's primary blast. And what remained left him breathless. It was a cascade of smaller, perfectly spaced subpulses. They were arranged not in a simple, repetitive beat, but in a sprawling, complex sequence that seemed to unfold with deliberate intent. Some pulses were long, others were short. Some were polarized vertically, others horizontally. The sequence wasn't repeating. Each massive burst from the magnetar carried a new, unique pattern within its echo, a fresh verse in a song whose language was utterly alien. A hushed silence fell over the control room. The quiet hum of the servers suddenly seemed deafening. The mundane became surreal. You could feel the shift in the air, the collective intake of breath, as every screen in the room was switched to display the anomaly. This was the moment that separates history into a before and an after. This was the moment the predictable universe began to dissolve. The frantic search for an explanation began immediately, a desperate attempt to reclaim solid ground in a world suddenly turned to quicksand. The first most logical suspect was human error, their own technology. Was it a newly launched satellite, its signal contaminating their data feed? They cross-referenced every known object in orbit, every satellite, every piece of space debris. Nothing. The signal was coming from a fixed point in the sky, a point that moved with the rotation of the Earth, a point precisely where the magnetar should be. It was not from our world. Could it be a flaw in the receiver, some subtle malfunction in the delicate electronics of the telescope itself? They called their counterparts at the Parkes Observatory in Australia, and then the 500-meter aperture spherical telescope in China. The request was urgent, almost frantic. Point your dishes at J1000, 740 Fibonacci, 2900. Now, tell us what you see. The hours that followed were some of the longest in the history of radio astronomy. The teams worked in a state of suspended animation, caught between the hope of a simple, mundane explanation and the terrifying, exhilarating possibility that they had found the impossible. Then the confirmations began to trickle in, first from Parkes, then from FAST. They saw it too. Their independent instruments, thousands of miles apart, were capturing the exact same intricately structured pattern. The signal was real. It was coming from deep space. And it was breaking the laws of physics. To understand the sheer magnitude of this discovery, you must first understand the brutal simplicity of nature at this scale. A magnetar is not a delicate instrument. It is a cosmic sledgehammer. It is a sphere of degenerate matter, so dense, a single teaspoon of it would outweigh Mount Everest, spinning at incredible speeds, caught in a magnetic field of unimaginable violence. The energy it releases is the product of pure chaotic physics. A starquake on its surface is like a billion hydrogen bombs detonating at once. The resulting blast of radiation should be a roar, not a whisper. It should be a tidal wave, not an intricate piece of origami. For such an object to produce a signal with fine, layered, non-repeating structure is like a volcano erupting in perfect Morse code. It is like a supernova exploding to form a flawless crystal lattice. It's not just unlikely. It is, by our current understanding, physically forbidden. Nature does not build with this level of complexity on this kind of energetic scale. The universe has two ways of creating patterns. One is through simple repetitive laws, the clockwork spin of a pulsar, the crystalline structure of a snowflake, the perfect sphere of a star. The other is through the beautiful branching chaos of fractal geometry, the shape of a coastline, the structure of a lightning bolt, the distribution of galaxies in a cluster. This signal was neither. It displayed the precision of the first and the infinite complexity of the second. As the data analysts began to dig deeper into the structure of the subpulses, the mystery only intensified. They found mathematical relationships embedded within the patterns. The spacing between some of the pulses corresponded to prime numbers. The polarization shifts when mapped out formed patterns that resembled complex fractal equations. The information density was staggering. Each brief pulse contained more structured data than is broadcast across all of Earth's telecommunication networks in a full minute. It was a signal with the apparent fingerprints of intelligence, a deliberate, calculated message broadcast with the power of a dying star. The team in the control room didn't speak of it aloud. The implications were too vast, too terrifying to articulate. But the thought was there, hanging in the silent air between them, reflected in the wide, disbelieving eyes staring at the screens. They were looking at a phenomenon that should not exist. A beast of pure physics, a celestial blowtorch burning at the heart of the galaxy, was sending a signal that appeared to be engineered. A ghost in the machine. A structured, intricate, mathematical ghost. We find ourselves now in the immediate aftermath of that discovery, standing on the precipice of a new reality. The data has been verified. The signal is constant. Every few seconds, another blast wave from the magnetar washes over our planet, and hidden within its fury is another verse, another complex piece of the impossible puzzle. We have, for the first time, encountered a phenomenon that our science cannot explain. Not because our theories are incomplete, but because it seems to violate the fundamental premise of those theories that the universe is a product of mindless, undirected natural law. This single inexplicable pulse from the dark has shattered our comfortable consensus. It has thrown open the doors of possibility so wide that the draft extinguishes every candle of certainty we once held. We are left in the dark with a single profound and deeply unsettling question. What is the source of this intricate pattern? Is it some new exotic form of physics, a natural process so alien to our experience that it mimics the complexity of life itself? Are we witnessing the universe's ability to generate information and structure in a way we never dreamed possible, a third path beyond simple repetition and beautiful chaos? Or is it something else? Is this the answer to Fermi's great paradox, the solution to the great cosmic silence we have been listening to for a century? Are we looking at the work of a technology so advanced that it can harness the most violent objects in the universe as a broadcast tower, a civilization that can write its message in the very heart of a stellar cataclysm? We do not know, but we are compelled to find out. The journey to decipher this celestial Rosetta Stone, to understand its origin and its meaning, begins now. It will take us to the edge of astrophysics, to the frontiers of information theory, and perhaps to the most profound revelation in human history. For 26,000 years, this message has been traveling through the void, a whisper encoded in a scream. And now, finally, someone is listening. How does a dead thing keep time? It's a paradox that sits at the very heart of our search for cosmic order. We look to the heavens for constants, for celestial anchors in the unending chaos of the universe, and we find them in the most violent and unlikely of places, the skeletal remains of suns. For most of human history, the night sky was a silent theater of serene, slow-moving giants. Its rhythms were the patient waltz of planets, the stately procession of constellations. But in the summer of 1967, a young graduate student named Jocelyn Bell Burnell, wading through miles of chart paper from a new radio telescope, found something else entirely. It was a strange rhythmic pulse, a faint bit of scruff on the data that appeared with a precision so unnerving, so utterly inhuman that the team half-jokingly labeled it LGM-1 for Little Green Men. That pulse, as we now know, was not a greeting from an alien civilization. It was the frantic spinning ghost of a star that had long since died. This was our introduction to the pulsar, the collapsed core of a massive star, an object so dense that a single teaspoon of its matter would outweigh a mountain. Crushed by its own gravity into a sphere barely the size of a city, it spins hundreds of times a second, a gravitational gyroscope of unimaginable power. From its magnetic poles, it fires out twin beams of intense radiation. And if the Earth happens to lie in the path of one of those beams, we see a pulse every time it sweeps past us, a cosmic lighthouse spinning in the dark. For half a century, pulsars have been our gold standard of cosmic precision. Their unwavering rhythm is so reliable that they can be used to test Einstein's theory of general relativity, to search for gravitational waves, and to map the very structure of our galaxy. They were the universe's clocks, predictable, understandable, and profoundly natural. They were the known, But the universe, it seems, has more than one way to scream into the void. In 2007, we detected a completely different kind of pulse, a new beast that defied all comparison, a fast radio burst, or FRB. If a pulsar is a metronome, an FRB is a cosmic flashbulb, a single blinding burst of radio energy, lasting only a few thousandths of a second, yet releasing as much energy in that instant as our sun does in an entire day. They are ephemeral, violent, and maddeningly unpredictable. Most appear once from a distant unknown galaxy and are never heard from again, a shout across billions of light years with no hint of its origin or cause. For years, these two phenomena defined the landscape of celestial pulses, the perfect clockwork rhythm of the pulsar and the chaotic solitary fury of the FRB. One was order, the other was chaos. There was nothing in between. At least, that is what we believed. Our story begins where the Earth scrapes the edge of space in the thin, cold air of the Atacama Desert in Chile. Here, the sky is not a gentle dome, but an abyss of crushing clarity, a place so dry and so high that the veil of our atmosphere is almost stripped away. It is an alien landscape on our own planet, a silent ochre world, chosen not for what is there but for what isn't. No cities, no lights, no radio chatter, no moisture to blur the cosmos. Upon this remote plateau sits the Cerro Verde Transient Array, or CVTA. It isn't a single majestic dish you might picture, but a sprawling forest of hundreds of smaller specialized antennas. They stand like a metallic congregation, their faces turned to the heavens, listening, not looking, but listening, tuned to the whispers and murmurs of the radio universe. They form a single continent-sized ear designed to catch the faintest, most fleeting signals from the deepest chasms of space and time. Presiding over this cathedral of silence is a small, dedicated tribe of scientific pilgrims. The team's lead, Dr. Aris Thorne, is a man seemingly carved from the desert itself, weathered, patient, and deeply skeptical. He'd spent 30 years listening to the static of the cosmos, a career built on distinguishing meaningful signals from the endless noise. His guiding principle was simple. Before you claim you've found something new, you must prove beyond any shadow of a doubt that it isn't just you, your equipment, or your own wishful thinking. His foil and protege was Dr. Lena Petrova, a brilliant astrophysicist whose fingers flew across keyboards as she translated the raw, chaotic data from the array into elegant models of cosmic physics. Where Aris saw potential errors, Lena saw nascent patterns, her mind a loom for weaving threads of disparate data into a coherent tapestry. And then there was Ben Carter, a doctoral student running on little more than caffeine and boundless enthusiasm, tasked with the thankless overnight job of system calibration. The digital janitor work that ensures the great ear of the CVTA is listening cleanly. The discovery, when it came, did not arrive with a thunderclap. It began as an irritation. It was 3 a.m, the desert outside, frozen under a blanket of stars so thick it looked like spilled salt. Ben was running a deep field calibration, pointing the array at a patch of sky thought to be profoundly reassuringly empty. The goal was to measure the baseline noise, the fundamental hiss of the universe itself. But there was a faint, persistent hiccup in the data, a tiny rhythmic spike in the noise floor that shouldn't have been there. It was infinitesimally small, a whisper that refused to be shushed. Ben swore under his breath, assuming it was a software glitch or a cooling pump in one of the receivers, creating a faint electronic pulse. He ran the diagnostic filters. The spike remained. He rebooted the subsystem. It was still there. Annoyance began to curdle into curiosity. He shifted the array's focus by a single arc-second, a sliver of the sky so small it's like singling out a single grain of sand on a mile-long beach. The signal vanished. He moved it back. It reappeared, faint but unwavering. Whatever it wasn't inside their equipment. It was out there. By sunrise, Ben had a preliminary file ready for Lena. He presented it with an apology, assuming he had wasted her time with some new form of local interference they hadn't yet catalogued. Lena, however, didn't dismiss it. She saw what Ben had seen. The signal was weak, but it was astonishingly persistent. She began to deconstruct it, applying a battery of algorithms to clean the data, to amplify the whisper buried beneath the roar of galactic noise. As the first clean pulse profile resolved itself on her screen, the atmosphere in the control room began to change. It wasn't the sharp, singular peak of a classic pulsar, nor was it the chaotic broadband splash of an FRB. This was something different. It was a primary pulse, strong and clear, but it was followed by a complex train of 5 subpulses. These echoes were not random. They followed a precise mathematical relationship, each one weaker than the last, decaying in brightness along a perfect logarithmic curve. And the entire sequence, the main pulse and its 5 trailing echoes, repeated. Not every second or every millisecond. It repeated every 17.342 seconds, precisely to the thousandth of a second. Every single time. The initial perplexity that had gripped Ben morphed into a palpable wave of intrigue that swept through the entire team. They had stumbled upon a cosmic metronome, but one playing a rhythm they had never heard before. It had the clockwork regularity of a pulsar, yet its internal structure was bafflingly complex. For 2 weeks, the CVTA remained locked on that single, unremarkable patch of sky. The team worked in a fugue state, grabbing sleep in shifts, the control room buzzing with quiet intensity. Every 17.342 seconds, the strange pulse arrived, a ghostly heartbeat from the void. It never wavered. It never changed its complex structure. It was so stable, so mathematically pure, that the initial thrill of discovery began to be replaced by a deeper, more unsettling feeling. Nature, for all its beautiful mathematics, is rarely this clean. There are always slight variations, jitters, imperfections. Stars quaver, orbits decay, emissions fluctuate. This signal, however, was perfect, too perfect. The intrigue that had animated them was now slowly, inexorably turning into a quiet, creeping alarm. This was the moment Thorne stepped in, his skepticism acting as a necessary anchor against the rising tide of speculation. He called a halt to the theoretical modeling. "Before we write the press release that makes us famous," he said, his voice low and steady, "we are going to do everything in our power to prove this is a ghost." He drew up a protocol, a gauntlet of tests, designed to kill the signal, to expose it as a phantom born of their own technology, or a misinterpretation of some mundane phenomenon. The great debunking had begun, and it would become an obsession, a methodical, painstaking process of elimination that would push the team to the very limits of their ingenuity. First, they attacked their own instrument, the CVTA itself. Every component was put under suspicion. Was it the rhythmic cycle of the cryocoolers that kept the receivers at temperatures near absolute zero? They took a dozen receivers offline, rerouted the cooling systems, and even shut down the main pumps for a full cycle. The signal persisted, unchanged. Could it be the digital correlator, the massive supercomputer that combines the data from the hundreds of antennas? A subtle clocking error in the central processor could, in theory, imprint a false rhythm onto the data. They switched to a backup correlator, a completely redundant system with its own independent timing source. The pulse arrived right on schedule with its 5 perfect echoes. They checked the power grid, searching for fluctuations. They examined the fiber optic cables that snaked across the desert floor, looking for signal reflection. They even considered the physical vibration of the antennas in the thin desert wind. Each possibility was modeled, tested, and ultimately dismissed. The phantom was not in their machine. Their focus then shifted outward to the near-Earth environment. The sky is now filled with our own technological chatter. Could it be a new unlisted military satellite in a peculiar orbit? Its radar sweeping across their location every 17.342 seconds. They cross-reference their detection with every known satellite catalog commercial, military and classified. There was nothing in that part of the sky at that time. Furthermore, the signal exhibited a crucial property known as dispersion. As a radio wave travels through the sparse plasma of interstellar space, lower frequencies are slowed down slightly more than higher frequencies. This causes the pulse to arrive a fraction of a second later at lower frequencies, smearing it out. By measuring the exact amount of this, smearing the dispersion measure, astronomers can calculate how much space the signal has traversed. When Lena ran the final calculation, a heavy silence fell over the control room. The dispersion measure was enormous. It wasn't a satellite. It wasn't an aeroplane. It wasn't even from our solar system. The signal had traveled through so much interstellar medium that its source had to be far outside our own Milky Way galaxy. It was an extragalactic signal originating from a distance of at least 500 million light-years. The realization landed with physical weight. This faint, persistent whisper was not a local call. It was a broadcast from across an almost unimaginable gulf of space and time. A message that had been traveling toward their desert observatory since before the first dinosaurs walked the Earth. This discovery should have been a moment of pure triumph, the confirmation of a new, profound cosmic phenomenon. Yet it only deepened the team's anxiety, because now they had to confront the universe itself. Aris, Lena, and Ben began the final, most daunting phase of their investigation, methodically ruling out every known or even theorized astrophysical source. Was it some bizarre new type of pulsar? They scoured the catalogs. Some pulsars exhibit complex subpulse structures, a phenomenon known as drifting, but never with this kind of rigid mathematical perfection. The energy profile simply didn't match. Could it be a magnetar, a neutron star with a magnetic field of terrifying intensity? Magnetar bursts were far more energetic and crucially sporadic. They were the product of violent starquakes on the star's surface, not the calm repeating tick of a clock. They lacked the stability that was the defining and most unnerving characteristic of their signal. They turned to more exotic possibilities. Perhaps it was a binary system, two compact objects like neutron stars or black holes, locked in a tight, rapid orbit. Could their interaction, their gravitational dance, produce a periodic emission? Lena spent a week running complex simulations, modeling every conceivable orbital configuration. The models produced pulses, yes, but they were messy. The gravitational forces would cause the orbit to decay, the timing to shift, the pulse shape to vary. Nothing she could create in the clean, predictable world of physics could replicate the unyielding crystalline perfection of the signal that continued to arrive every 17.342 seconds from 500 million light-years away. They had systematically, one by one, eliminated every possible culprit. They had interrogated their equipment, their planet, and the known laws of astrophysics. Each investigation returned the same verdict: not guilty. The signal was not an error. It was not terrestrial. And it did not conform to any natural phenomenon we have ever observed. Weeks had bled into a month. The team was exhausted, hollowed out by their relentless circular investigation. The initial thrill was a distant memory, replaced by a profound sense of intellectual vertigo. They were standing at the edge of a map, staring into the blank space, where the cartographer had simply written, "Here be dragons." Aris Thorne, the hardened skeptic who had built a career on finding the mundane explanation, now found himself staring at the pulse profile on the main screen, his face illuminated by its eerie green light. He had exhausted his skepticism. He had run out of conventional answers. The process of elimination had not solved the mystery. It had amplified it into something monstrous. With every natural cause methodically stripped away, they were left alone in the silent observatory, facing a possibility so profound, so paradigm-shattering, it felt like heresy to even think it. The universe was sending them a pattern, and for the life of them they could not understand how it was doing it naturally. And so the vigil began. What started as a flicker of curiosity, a whisper of something unusual in the data from PSRJ 1748-2446 AD, now became an obsession. The world's great radio eyes, vast steel dishes that drink from the fire hose of cosmic information, were all slowly swiveling one by one to stare into that same unremarkable patch of sky. At first, it was a covert operation, a handful of astronomers calling in favors, booking precious telescope time under the guise of routine pulsar surveys. No one wanted to announce the hunt for a ghost, not yet, but the ghost wouldn't stay quiet. With every rotation of the Earth, a new observatory would pick up the trail, its data streams joining the torrent pouring into servers in Socorro, in Greenbank, in Jodrell Bank. The initial signal, that faint, rhythmic oddity, was no longer a fragile hint buried in a mountain of noise. It was now being etched into the record by a dozen independent instruments, each observation a separate, damning piece of evidence. The pattern wasn't just real, it was shockingly, impossibly precise. The initial skepticism, that healthy, necessary armor of the scientific mind, began to crack. You could almost hear it, a collective shattering of assumptions in chat logs and late-night video calls across continents. This wasn't an instrument glitch. A glitch doesn't appear identically in West Virginia and in the Australian outback. It wasn't atmospheric interference. The heavens don't conspire to create the same phantom in telescopes separated by thousands of miles. The data was a rising tide, and it was drowning every simple explanation we had. The pulse, that cosmic lighthouse beam, was supposed to be a model of celestial consistency. We had built our understanding of neutron stars on their metronomic precision, their unwavering rhythm that could keep time better than any clock on Earth. This object, however, wasn't playing by those rules. The weird pattern was a nested set of complexities, a series of mathematical matryoshka dolls. There was the primary pulse, beating hundreds of times per second as expected. But layered on top of it was a secondary rhythm, a subtle modulation that waxed and waned over a period of several hours. And even that rhythm wasn't stable. It was itself being warped, stretched, and compressed over a much longer cycle, a grand, overarching cadence that took days to repeat. Imagine trying to decipher a drum beat, only to realize the drummer is also riding a merry-go-round, which is itself perched on the deck of a ship rocking in a heavy swell. This was the challenge we faced. We were seeing a simple event, the rotation of a star, through a lens of such profound complexity that it defied our models. The periodicity wasn't just complex, it was maddeningly structured. When the team ran the signal through advanced Fourier analysis, the resulting chart wasn't the clean spike of a pulsar. It was a forest of interlocking peaks, a filigree of harmonics and subharmonics so intricate it looked less like a natural phenomenon and more like a deliberate composition. It was a symphony of impossibilities, played on an instrument we couldn't identify, broadcast from a concert hall in the void. The debate, once confined to hushed conversations, now erupted. Email chains exploded. Theoretical astrophysicists who live and breathe the mathematics of the cosmos were pulled from their abstract worlds into this very specific, very concrete mystery. The first line of attack was to try and force our existing understanding to fit. Perhaps some argued it was a binary system of unprecedented configuration. Two neutron stars locked in a bizarre, eccentric dance, their magnetospheres clashing and interfering in just the right way to produce this signal. The models were run supercomputers, churning for weeks, simulating every possible combination of mass, spin, and orbital decay. The results were tantalizingly close. The simulations could reproduce parts of the pattern, the secondary rhythm perhaps, or a hint of the longer cycle. But they could never replicate the whole thing. There was always a residual signal left over, a stubborn ghost frequency that refused to be explained. It was like solving a complex equation and always being left with the same irrational number on one side. The binary model, as beautiful as it was being slain by this one ugly, persistent fact. With the failure of the conventional, the truly exotic ideas began to emerge. The signal's unwavering stability, even within its complexity, suggested an object of immense density and gravitational authority. This led to the hypothesis of an entirely new class of star. For decades, we have theorized about what might lie beyond a neutron star on the scale of cosmic density. If you keep crushing matter, what happens next? One idea is the quark star, or a strange star, a sphere not of neutrons, but of their fundamental constituents, quarks existing in a soup of matter so bizarre it would rewrite our understanding of physics. Could this be the first glimpse of a quark star's crust might vibrate in ways a neutron star's couldn't, producing precisely these kinds of complex nested oscillations? It was a breathtaking idea, the discovery of a new state of matter in the cosmos. It would be a Nobel Prize guaranteed. The team chased this theory with a ferocious intensity, building models of quark-degenerate matter, exploring its resonant frequencies. The problem was energy. To produce a radio beam as powerful as the one we were detecting, the object needed a stupendous magnetic field 1 trillion times stronger than Earth's. The quark star models, however, struggled to generate such a field. In fact, some theories suggested their exotic nature would preclude the formation of a stable, powerful magnetosphere altogether. The hypothesis created a paradox. The very properties that might explain the intricate timing of the pulse seemed to forbid the existence of the pulse itself. It was a theoretical dead end, another beautiful idea collapsing under the weight of the evidence. Each competing theory felt like an intellectual life raft, eagerly seized upon by the team, only to dissolve in their hands as they examined it more closely. Every new explanation they devised, no matter how clever, seemed to create more problems than it solved. The universe wasn't just handing us a puzzle, it felt like it was actively mocking our attempts to solve it. Then came the planetary interaction hypothesis, a more visceral and violent scenario. What if this wasn't about the star alone, but about a doomed companion? Imagine a planet not of rock or gas, but a Chthonian remnant, the super-dense core of a gas giant that was long ago stripped bare by the star's radiation. Or perhaps even a diamond planet, a world of crystallized carbon caught in a gravitational death spiral. As this impossibly dense world whipped through the star's magnetosphere, it would be subjected to forces beyond all imagining. It would carve a tunnel of plasma in its wake, creating a complex circuit, a kind of cosmic electrical generator that would modulate the star's radio beam. The planet's orbit, its rotation, even the fracturing of its own crust under the tidal stress could all imprint their own frequencies onto the signal, creating the symphony we were detecting. This was a compelling narrative, a story of cosmic violence on a scale that humbled the imagination. It accounted for the complexity, offering multiple physical mechanisms to generate the nested periodicities. For a few frantic weeks, this became the leading theory. The team worked backward, trying to design a planetary system that would perfectly match the observed signal. They needed a planet of a specific mass, on a specific orbit, with a specific magnetic field of its own. But the math was stubborn. The system they designed had to be so fine-tuned, so perfectly balanced, that it bordered on the absurd. The orbital decay required to generate the energy didn't match the long-term stability of the signal. The plasma interactions that could explain the secondary modulation failed to account for the larger multi-day cycle. It was another near miss. The model was an exquisite piece of machinery, but it was designed to play a slightly different tune than the one the cosmos was broadcasting. The signal was not just complex, it was too stable, too clean, too perfect in its intricacy. The chaos of a planet being torn apart should be messy, unpredictable. This was the opposite of messy. This was architecture. Amidst this frantic search for answers, a human drama was unfolding. The team was sitting on the biggest astronomical discovery in a generation, and they were beginning to buckle under the pressure. The world of science is collaborative, but it is also fiercely competitive. They knew that other teams, drawn by the sheer strangeness of this object's radio emissions, would eventually point their own telescopes at it. The secret could not be kept forever. They were in a race not just against other scientists, but against time itself. The urgency to publish was immense, a constant low-grade hum of anxiety in the lab. A discovery of this magnitude is a legacy, but only for the first to announce it, yet the fear of being wrong was even greater. To go public with a claim this extraordinary, you had to be certain. To announce a new type of star only to have it revealed as a subtle software bug or an overlooked plasma effect would be a career-ending humiliation. The lab became a pressure cooker. Arguments broke out over statistical significance, over the interpretation of a single data point. Friendships were strained as exhaustion set in. One faction pushed for immediate publication, arguing that they had done their due diligence, that every conventional explanation had been tested and had failed. They believed it was time to present the anomaly to the wider community, to admit that they were stumped, and to invite the world's best minds to help solve the puzzle. To withhold the data, they argued, was a disservice to science itself. Another faction urged caution, pleading for more time, for one more simulation, one more attempt to find a mundane explanation. They were haunted by the ghosts of scientific history, by past discoveries that turned out to be nothing more than cold weather interference or loose cables. They saw the precipice and were terrified of the fall. The very nature of the signal seemed to demand this impossible standard. It was so clean, so structured, that it felt like it had to be either something utterly profound or something utterly trivial. There was no middle ground. Their struggle was a perfect reflection of the scientific method itself, a grueling, emotional, all-too-human battle between the thrill of discovery and the terror of error. They were charting unknown territory, and every step was fraught with peril. They were staring at a message from the deep cosmos, a pattern so articulate and yet so alien that it challenged the very foundations of their field. And as they prepared their paper, cross-checking every number, debating every single word, a new, even more disturbing possibility began to emerge from the endless stream of data. The pattern, the intricate, multi-layered rhythm they had spent months trying to understand, wasn't just stable. It was beginning to change. Slowly, almost imperceptibly, the grand, overarching cycle was shrinking. The symphony was speeding up. This wasn't a static puzzle. It was a dynamic one. The enigma was evolving right before our eyes. And we were about to tell the world about an object whose behavior we had just realized we couldn't even begin to predict. Months had bled into one another, each one a testament to diminishing returns. The initial euphoric rush of discovery had long since curdled, leaving behind the bitter residue of exhaustion and intellectual stalemate. Inside the operations center, the air itself seemed weary, thick with the scent of stale coffee and the low, omnipresent hum of cooling fans wrestling with server heat. Outside the colossal dish, a monument to human curiosity continued its silent, dutiful vigil, drinking in the whisper from deep space. But inside, the scientists tasked with translating that whisper were adrift in a sea of static. The pulse was a ghost, a stubborn enigma wrapped in layers of cosmic noise. Every theory, every elegant model proposed to explain it, had shattered against the unyielding wall of the data. It wasn't a pulsar. The periodicity was too erratic, drifting like a ship without an anchor. It wasn't a magnetar. The energy profile lacked the violent, cataclysmic signature of a starquake. It wasn't a binary system. No orbital mechanics could account for its bizarre cadence. The team, a collection of the finest minds in radio astronomy, had thrown the entirety of their collective knowledge at the problem, only to watch their hypotheses dissolve into statistical irrelevance. They were chasing a phantom through a blizzard of numbers, and the trail had gone cold. In a quiet corner of the data processing lab, far from the heated debates of the senior staff, a junior researcher was engaged in the digital equivalent of sweeping the floors. Her name would never be the one attached to the grand theories. Her role was far less glamorous, a meticulous, almost thankless task. She was a data hygienist, tasked with cleaning the terabytes of raw signal that poured in every day. Her job was to hunt for terrestrial interference, to flag corrupted data packets, to scrub away the grime of Earth's own electronic cacophony. The stray mobile phone signals, the faint chatter of orbiting satellites, the electronic ghosts of military radar. She was supposed to be the guardian of the signal's purity, ensuring that what the astrophysicists analyzed was truly from the stars and not from a nearby microwave oven. For weeks, her world had been a landscape of waveforms and spectrograms, a monotonous terrain of noise, spikes, and baseline drift. She had developed an intuitive feel for the data's texture, the familiar jagged patterns of galactic hydrogen, the smooth curve of blackbody radiation. She knew the signal's personality, its quirks, its rhythms. And that is why on the third Tuesday of the 9th month of observation, something caught her eye. It wasn't a dramatic flare. It wasn't a loud, intrusive burst. It was the opposite. It was a subtle, persistent thread of order, a strange coherence hiding deep within the signal's chaotic fluctuations. At first, she dismissed it. It was an artifact, it had to be. A new piece of software in the processing pipeline, perhaps introducing a harmonic error, or maybe a recursive loop in her own filtering algorithm, a snake eating its own tail. It was too clean, too delicate to be real. Nature on this scale was a blunt instrument. It used overwhelming force, gravitational hammers, and electromagnetic sledgehammers. It did not, as a rule, engage in intricate embroidery. She diligently set about trying to eliminate this ghost in the machine. She reran the raw data through older versions of the processing software. The pattern remained a faint but unwavering watermark. She cross-referenced the timestamps with the logs of every known satellite, every flight path, every registered radio broadcast within a 1,000-mile radius. There were no correlations. The pattern was not from Earth, nor was it from our immediate orbital neighborhood. It was arriving with the pulse itself, inseparable from the primary signal. Her frustration mounted. This phantom was polluting the data, a stubborn stain she was failing to remove. Her job was to provide clean data, and this was a contamination of the highest order. She began to apply more aggressive digital filters, tools designed to isolate and excise specific frequencies. But the pattern was unlike anything she had ever encountered. It wasn't a single frequency, a simple tone that could be notched out. It was spread across the entire bandwidth of the pulse, woven into its very structure. Trying to filter it out was like trying to remove the threads of a single color from a complex tapestry without unraveling the entire image. The more she tried to erase it, the more she realized it wasn't an error painted times on times the signal. It was part of the signal's fundamental architecture. A profound shift began to occur in her thinking, a slow, terrifying turn from annoyance to awe. What if her entire premise was wrong? What if she wasn't looking at a stain to be cleaned, but at a message to be seen? With trembling hands, she abandoned her cleaning protocols. She stopped trying to remove the anomaly, and for the very first time, she tried to isolate it. She wrote a new piece of code, not a filter, but a demodulator. An algorithm designed not to subtract, but to amplify this strange hidden coherence. She was treating the background noise of the pulse not as noise at all, but as a carrier wave, a vessel for something else, something hidden within. She hit execute, and the progress bar crawled across her screen, the servers behind her humming a steady, indifferent chorus. The seconds stretched into an eternity. This was a shot in the dark, a wild hunch born of desperation, a career-limiting move if she was wrong, presenting a data artifact as a discovery. But then the process finished, and her world fell away. On her screen, a shape began to resolve itself from the static. It was not a simple sine wave, not a neat geometric shape. It was a cascade of infinite detail, a visualization of breathtaking complexity, a fractal. Not just any fractal, but a structure of such profound mathematical intricacy that it made the familiar Mandelbrot set look like a child's drawing. It was a universe of self-similar patterns, spirals, that contained smaller, perfect copies of themselves, which in turn held even smaller spirals branching into infinity. It was fluid, evolving with each successive pulse, yet its underlying mathematical grammar was perfectly consistent. It was a shape that whispered of recursion, of complexity, born from a simple, elegant rule repeated endlessly. She stared, unable to breathe, her heart hammering against her ribs. The blood drained from her face. She felt a dizzying vertigo, the sense of standing on the edge of a cliff so high the ground was lost in the clouds. Astrophysics does not create this. The chaotic turbulence of a nebula, the violent death of a star, the crushing gravity of a black hole, these are forces of awesome power, but they are not subtle, they are not precise. They do not encode the language of pure mathematics into the modulation of a radio signal across thousands of light years. Nature can produce approximations of patterns, the hexagonal cells of a honeycomb, the spiral of a galaxy, the fractal patterns of a snowflake. But those are emergent properties born from the clumsy push and pull of physical laws. They are beautiful, but they are imperfect. They contain flaws. This was different. This was perfect. The mathematical constants that defined its structure were resolved to an impossible degree of precision. There was no fuzziness, no statistical noise. It was the pure crystalline signal of a theorem. It was a fingerprint. Not of a star, not of a cosmic process, but of a mind. Finding this embedded in the radio waves from a distant star was like walking on a barren, lifeless planet and finding a perfectly machined Swiss watch still ticking. It was the absolute, unambiguous, terrifying evidence of manufactured intent. The universe as we knew it had been a place of magnificent, unthinking natural processes. But in the space of a single keystroke, that universe was gone. We now lived in a universe that contained at the very least one other intelligence, and it was an intelligence of staggering sophistication. She ran the analysis again, and a third time, and a 10th. She rebooted the system, checked the code for errors line by line. The result was always the same. The fractal bloomed on her screen, a silent, intricate flower in a desert of static. It was real. She pushed her chair back, the sound screeching in the silent lab. Her legs felt weak as she stood up and walked almost in a trance toward the office of the project's lead astronomer. She didn't knock. She simply opened the door. "Doctor." Aris Thorne looked up, his face etched with the familiar lines of fatigue and frustration. "What is it?" he asked, his voice flat, expecting another dead end, another failed theory. She couldn't form the words. Her throat was tight with a mixture of terror and exhilaration. She simply pointed back toward her workstation. You need to see this." The skepticism on his face was a mask of stone. He had seen a dozen breakthroughs in the last few months, each one dissolving under scrutiny into wishful thinking or simple error. He followed her, his posture radiating weary impatience. She sat down, her hands shaking as she typed the command one last time. He stood behind her, arms crossed, ready to gently but firmly point out her mistake. And then it appeared. The same impossibly intricate pattern unfurling itself on the screen, a message written in the language of cosmic creation. Aris Thorne said nothing. The silence in the room became absolute, a vacuum that sucked all the air out. He leaned closer to the monitor, his eyes wide. The color drained from his face, replaced by a pale, ghostly sheen. He reached out a hand, his fingers hovering just inches from the screen, as if he could touch this impossible thing, as if to confirm it was real. "My God," he whispered. The words were not an exclamation, but a prayer. He understood in an instant. Every natural explanation they had fought over for months was incinerated in the light of this one image. This wasn't a signal to be explained by physics. This was a signal to be times deciphered, asterisk. The debate was over. Not just the debate in their lab, but the great centuries-long debate of humanity. Are we alone? The answer, blooming in hypnotic detail on a dusty monitor in the middle of the night, was no. The pulse from the heavens was not a celestial lighthouse. It was a letter, a cosmic Rosetta Stone delivered to our doorstep. And it was a letter of such profound intellectual density that it made our own greatest achievements seem like the scrawlings of a child. The news did not explode through the facility. It crept, a hushed whisper from Thorne to his most trusted colleagues, a shared glance over a monitor, a quiet, urgent convening in a locked conference room. The atmosphere in the observatory transformed. The fog of frustration evaporated, replaced by a chilling electric tension, a mixture of profound wonder and a deep primal fear. Every hum of the servers, every tick of the clock now felt portentous. The data streaming down from the dish was no longer a scientific curiosity. It was the voice of another. The question that now hung in the air, unspoken but felt by all, was terrifyingly simple. What does it say? And the even more chilling question that followed close behind, what does one do when you learn that you are no longer the smartest thing in the creation? The world outside was sleeping blissfully unaware that everything it thought it knew about its place in the cosmos was about to be changed irrevocably and forever. Human history had just been cleaved in two, the time before the pattern and the time after. And these few frightened, exalted scientists were the only souls on the planet who knew it. They were now the keepers of the most significant and perhaps the most dangerous secret in all of human existence. Their burden was no longer merely scientific. It was existential. And so the dam of secrecy, built of caution and disbelief, finally broke. Not with a trickle, but with a tidal wave of information that inundated the globe in a single heart-stopping moment. The revelation from Arecibo, the elegant mathematical proof nested within the pulse, was no longer the protected secret of a few hundred scientists and officials. It became the shared property and the shared burden of 8 billion human souls. Across the planet, a strange new silence fell, followed by a roar. It was the sound of televisions and radios in every home, every cafe, every public square, all tuned to the same breaking story. The sound of phones ringing, of networks crashing under the strain of a species simultaneously reaching out for confirmation, for comfort, for an explanation. You might have been at work, your screen suddenly filling with alerts, or perhaps you were driving, the familiar cadence of music on the radio, interrupted by a solemn, urgent voice. Wherever you were, whatever you were doing, your life, like everyone else's, was now cleaved into two distinct eras, the time before we knew and the time after. The initial reaction was a global collective gasp of pure wonder. For a few breathtaking hours, the old divisions seemed to melt away like frost in the morning sun. In cities from Tokyo to Tehran, from Lagos to Lima, strangers gathered on street corners not in fear, but in a shared hypnotic trance, their faces upturned to the sky as if they could somehow see the source with their own eyes. It was a sky that looked the same as it always had, yet was now profoundly, irrevocably different. It was no longer just a canopy of stars, it was a cosmic neighborhood, and we had just heard a knock on the door. This wave of unity, this sudden powerful sense of a single human family staring into the great unknown, was as beautiful as it was fleeting. Because awe is a difficult emotion to sustain, and it is almost always followed by its darker twin fear. The questions began as whispers then grew into a cacophony of anxiety. If they are out there, who are they? If they are intelligent enough to send this message across the void, what are they capable of? The signal, which had first seemed like a beacon of hope, began to feel like a cosmic sonar ping, and we were the ones who had just been found. Paranoia, a deeply ingrained evolutionary trait, began to curdle the initial wonder. New cults bloomed overnight, their charismatic leaders preaching that the pulse was a divine message, a rapture signal, or a precursor to celestial judgment. Conspiracy theories, always simmering beneath the surface of society, erupted with volcanic force. To some, the signal was an elaborate government hoax, a Project Blue Beam scenario designed to usher in a new world order. To others, it was a weapon, a sophisticated alien virus delivered via radio waves set to rewrite our DNA or control our minds. The global markets, those sensitive barometers of human confidence, swung violently. Defense stocks surged, while technology and consumer goods plummeted as uncertainty choked investment. Supermarket shelves in some regions were stripped bare, the primal fear of the unknown driving people to hoard resources just in case. We had spent our entire existence as a species, defined by our conflicts with each other. Now, for the first time, we faced the concept of an us and a them, on a scale so vast, it fractured the human psyche. While the public grappled with this existential whiplash, the halls of power were gripped by a quiet, controlled panic. In Washington, Beijing, Brussels, and Moscow, emergency sessions were convened, their agendas stripped of all previous geopolitical squabbles. Suddenly, trade disputes and border conflicts seemed like the petty arguments of children in a world that was no longer exclusively theirs. The first challenge was simply one of comprehension. Generals, presidents, and prime ministers, men and women accustomed to dealing with tangible threats, were now briefed by bewildered astrophysicists on subjects like hydrogen line frequencies and binary encoded prime numbers. They were being asked to formulate a strategy for the single greatest unknown in human history, with no precedent, no playbook, and no time. An emergency summit of the United Nations Security Council was called, but it quickly devolved into a microcosm of the global confusion. Some nations, led by a new bloc of cautious states, argued for a policy of absolute silence. To reply, they insisted, was to shout into a dark forest, potentially revealing our location to a predator we could not possibly understand. They invoked the tragic histories of isolated civilizations on Earth, which were almost invariably destroyed upon contact with more technologically advanced cultures. Why, they asked, would contact on a cosmic scale be any different? Others argued for the opposite, advocating for an immediate, powerful response. This was not a moment for fear, they proclaimed, but for humanity to announce its presence, to take its rightful place on the galactic stage. To remain silent would be an act of cowardice, a betrayal of the very spirit of exploration that defined us. Behind this public debate raged a frantic clandestine struggle for control. Military intelligence agencies worked feverishly to determine if the signal could be a threat vector. Could it contain malicious code capable of infecting our global communication networks? Could its frequency be a precursor to a directed energy weapon? Space agencies, once purely scientific bodies, were quietly militarized, their deep space network dishes repurposed not just for listening but for surveillance. A new, fragile global entity began to take shape, born of necessity. It was called the Arecibo Commission, a consortium of the world's leading scientific minds, political strategists, and ethical philosophers, tasked with a monumental responsibility to manage humanity's first contact. Their immediate goal was not to respond, but to understand. And to do that, the very nature of the scientific investigation had to change. The puzzle was no longer about the where. The source had been triangulated to a stable point in the Ophiuchus constellation, a tantalizingly close neighbor in galactic terms, though still centuries away for our fastest probes. The question that now consumed every waking moment of the scientific community was the what. What was this intelligence trying to tell us? The pivot was seismic. The world of radio astronomy, which had held the spotlight for months now, became just one piece of a much larger, more complex intellectual machine. The signal's raw data, that stream of ones and zeros that had already yielded the stunning proof of its artificial nature, was released to the global academic community. And from every corner of human knowledge, new experts were drawn into the orbit of the mystery. Cryptographers from the world's most secretive intelligence agencies, who had spent their careers breaking human codes, now found themselves staring at a cipher crafted by a mind that did not share a single byte of our evolutionary or cultural history. They ran the binary sequence through every decryption algorithm known to man, searching for keys, for repetitions, for statistical anomalies that might betray a hidden layer of language. Their initial findings were maddening. The signal was intensely structured, yet it resisted every conventional method of attack. It was as if someone had given us a locked chest of unimaginable complexity, but had neglected to provide even the concept of a key. Then came the linguists, experts in ancient dead languages, and theoretical grammatical structures were brought in, their task seemingly impossible to find the syntax of an alien thought process. They looked for patterns that might function as nouns or verbs. They tried to identify if the prime number sequence was a form of punctuation, a way of marking celestial sentences or paragraphs. They debated whether a language born under a different star, perhaps by a creature with a different sensory apparatus, would even be recognizable as language to us. Could they communicate in pure mathematics, a universal language we shared? Or was that very assumption a fatal form of anthropocentric hubris? Mathematicians, too, descended upon the data, their approach different from the cryptographers. They weren't just looking for a code to break, they were looking for a deeper truth to unveil. They mapped the long prime number sequence onto complex geometric shapes, hoping to find a visual representation. They explored whether the timing between the pulses correlated with undiscovered physical constants or the decay rates of exotic particles, suggesting a message about the fundamental laws of the universe itself. Biologists and chemists joined the effort, theorizing that the message might not be philosophical but practical. Could the sequence be a map of a complex organic molecule, a recipe for life itself? They overlaid the patterns against the known structure of DNA and RNA, searching for a familiar helix, a sign of shared biology. But the signal remained stubbornly opaque, a monument of alien intellect that we could recognize as artifice, but could not begin to comprehend. The Arecibo Commission set up centers of study around the world, fostering a collaboration unprecedented in its scale and scope. Old academic rivalries were set aside. Research that would normally have been kept secret for years was shared instantly on secure networks. It was humanity's finest moment, a unified global quest for knowledge, all of it driven by that single, unrelenting pulse from the stars. For months, this was the new normal. The world held its breath while its brightest minds worked. The signal continued its steady metronomic beat, a constant in a world of turmoil. It became a part of our culture, the background rhythm of our lives. Artists were inspired by it, musicians sampled its frequency, and for a time we grew almost comfortable with its presence. We began to feel we had time. The message was ancient, its senders were distant, and the puzzle, while profound, was one we could work on for generations. That illusion was shattered on a Tuesday. At the Very Large Array in New Mexico, a young postdoctoral researcher named Dr. Aris Thorne was running a routine diagnostic on the signal's carrier wave, the foundational frequency upon which the binary pulses were encoded. For nearly a year, this wave had been the one thing about the signal that was perfectly immutably stable, a pure, unwavering tone at 1,420 MHz. The hydrogen line, the most logical and universal frequency to choose for interstellar communication. It was the cosmic channel one. But on that Tuesday, it wasn't stable. Thorne's screen showed a subtle, almost imperceptible drift, a modulation. He ran the diagnostic again, assuming it was an atmospheric anomaly or an equipment malfunction. But the drift was still there. It was real, and it wasn't random. Frantically, he cross-referenced with other observatories in Chile and Australia. They were all seeing the same thing. The carrier wave, the bedrock of the entire message, was changing. It was being deliberately and intelligently manipulated. Panic and exhilaration ripped through the scientific community in equal measure. This was not a pre-recorded message left on a cosmic answering machine centuries or millennia ago. This was not a lighthouse sweeping its beam across the galaxy for anyone to see. The change in the carrier wave could only mean one thing. The signal was live. The intelligence on the other end was active. And worse, far worse, the modulation wasn't just a simple change. When the new data was analyzed, it revealed a second layer of information, a breathtakingly complex wave pattern now riding on top of the original. It was like discovering that a book you've been struggling to read contains an entirely separate, invisible text written in the faint watermarks on every page. The original binary pulse, the sequence we had spent a year trying to decode, was suddenly relegated to the status of a simple greeting card. This new layer was the letter itself. The revelation sent a shockwave of terror through the Arecibo Commission and the world's governments. Every comforting assumption we had made about time and distance was now suspect. If the signal was live, how could that be possible? The source was still confirmed to be dozens of light-years away. There was no way for them to have detected our discovery and altered their transmission in response. The time delay would be decades long. Unless their physics was not our physics? Unless their understanding of space-time allowed for something we considered impossible, or a far more chilling possibility began to take hold in the minds of the strategists. What if the source was not where we thought it was? What if the powerful signal from Ophiuchus was just a diversion, a brilliant piece of cosmic misdirection? What if the sender was much, much closer, perhaps hiding in the Kuiper belt, or even fiving the Oort cloud, using a relay to make their transmission appear to come from much farther away? The sky, which had become a source of wonder, suddenly became a veil behind which anything could be hiding. The questions cascaded, each one more terrifying than the last. Why change the signal now? Was it a response? Had they somehow detected the focused radio energy of our own planet's civilization, the bubble of communication signals we have been leaking into space for a century? Was this new complex percent layer a sign of impatience, a more detailed introduction, or a warning? The scientific quest for knowledge was instantly overshadowed by an urgent need for security. The shift from academic problem to potential existential threat was immediate and absolute. The linguists and mathematicians were no longer just scholars. They were now humanity's first line of defense. The only people who might be able to interpret the intentions of an intelligence that was not only alien, but demonstrably active and observing. The weight of their task became almost unbearable. And as they began their frantic, desperate work on this new, impossibly intricate layer of the signal, the most profound and dangerous question of all finally settled upon us. The original message was a statement, "We are here." This new evolving message seemed to be asking a question directed squarely at us, at our small, blue, terrified world. It was a question of intent, a challenge posed across the void. The pulse was no longer just a knock. Now we could hear the sound of the lock turning, and we had no idea what was about to step through the door. The quiet confidence of the last few months had been shattered. Gone was the predictable clockwork precision of the signal, the comforting rhythm that had become the planet's shared heartbeat. In its place was a cascade of complexity, a torrent of new information flooding from the void. The ghost in the machine had not just woken up. It had begun to speak in a language of dizzying, almost terrifying intricacy. What had been a simple, elegant melody was now a symphony, and humanity had just been handed the conductor's baton without a single page of the score. The old rules were gone. The old assumptions which we had so painstakingly assembled were rendered obsolete in a single transformative pulse from the darkness. This change triggered a response unprecedented in human history. The era of isolated research teams competing for glory was over-ended, not by committee or treaty, but by necessity. From the Atacama Desert to the frozen plateaus of Antarctica, from the Deep Space Network hubs in California to the new lunar observatories silently watching from above, a new consensus emerged with breathtaking speed. We would face this together, or we would fail alone. And so the Arecibo Protocol was invoked, a theoretical framework for global cooperation that was now suddenly our only hope. Data streams, once proprietary and jealously guarded, were merged into a single planetary-scale network. Supercomputers on 3 continents were linked, their processing power chained together to form a singular globe-spanning mind dedicated to one task: to listen. This new entity, unofficially christened Project Chimera, was a fusion of disciplines that would have been unthinkable just a year prior. It was no longer just the domain of radio astronomers. Into the fold came quantum physicists struggling to model the signal's bizarre phase modulations. Cryptographers, veterans of digital wars, now stared at a code with no conceivable author. We brought in neurolinguists, experts in how intelligence structures language, hoping to find a familiar pattern, a ghost of grammar hidden in the mathematical torrent. We even invited musicians and artists, asking them to perceive the signal not as data, but as structure, as aesthetics. We were searching for the intention, for the soul of the message, believing that any intelligence, no matter how alien, must share some fundamental appreciation for elegance and form. You could feel the pressure mounting in every corner of society. The signal was no longer an academic curiosity. It was a constant living presence. Its core frequencies were converted into an audible hum, a low, resonant thrum that was broadcast globally, a constant reminder of the great enigma hanging over our heads. It became the soundtrack to our lives. You'd hear it in cafes, in subway stations, in the quiet moments before falling asleep. The question was on everyone's lips, whispered in 1,000 different languages. What is it trying to tell us? The burden on the men and women of Project Chimera was immense. They worked in relentless shifts fueled by caffeine and a terrifying sense of historic responsibility. Every failed hypothesis, every dead-end algorithm felt like a personal failure, a betrayal of the 7 billion people waiting for an answer. The early weeks of this new phase were a portrait of frustration. The signal's complexity was a perfect fortress. It contained layers upon layers of information nested like Russian dolls, but each layer seemed to be encoded using a key from the layer inside it. To understand the message, you already had to understand the message. It was a perfect recursive paradox. It was a lock that was also its own key. Teams in Kyoto would spend weeks analyzing a fractal pattern in the amplitude, only to find it was a reflection of a prime number sequence being transmitted on a different frequency, a sequence that a team in Johannesburg was treating as a completely separate phenomenon. It was a multi-dimensional conversation, and we were trying to comprehend it with three-dimensional minds. The signal was not a simple linear text to be read from left to right. It was a hologram, a complete image that had to be viewed from the right perspective to be understood at all. The breakthrough, when it came, was not a sudden lightning strike of genius. It was quieter, more profound. It began with a small team of mathematicians at CERN who were tasked not with decoding the signal, but with ignoring its content entirely. Their job was to analyze its times, structure times, its deepest mathematical architecture. They noticed something strange, something that had been dismissed by others as noise or a systemic artifact. It was a constant, a specific, irrational number that appeared again and again embedded in the very fabric of the transmission. It wasn't pi, it wasn't the golden ratio. It was a number we had never seen before, a fundamental constant that seemed to govern the relationship between different parts of the signal. It was the signal's own private law of physics. Let us call it the Laniakea constant, named for the supercluster our galaxy calls home. This constant was the Rosetta Stone we had been praying for. It was the universal translator not for a language of words, but for a language of relationships. When the teams applied the Laniakea constant as a decryption key, the chaos began to resolve into order. The nested paradoxical layers of the signal began to unwind. The cryptographic fortress, so impenetrable from the outside, simply dissolved when the correct key was turned. What we had perceived as 1,000 different competing signals was revealed to be one coherent, unified statement. The symphony, once a cacophony, began to resolve into a clear, stunning harmony. For the first time, we were not just hearing the signal, we were beginning to understand its composition. The first layer to crystallize was a stunning act of cosmic generosity. It was a primer, a user's manual for the message to come. It began by establishing fundamentals. It transmitted a model of a hydrogen atom not as a picture but as a series of resonant frequencies that matched its electron shell transitions. It was a universal greeting using the most common element in the universe as a shared foundation. From there it built outwards. It established the speed of light as a baseline measurement. It defined Planck's constant. It was a tutorial in the laws of physics, a confirmation that we were living in the same universe, governed by the same essential rules. It was the greatest hello in human history, a message that said, "We see that you are here, and we know that you see this too." But this was just the preamble. Armed with the Laniakea constant and with the basic universal dictionary, the primer had provided Project Chimera pushed deeper into the heart of the message. The next layer was where our perception of reality began to fray at the edges. It was a map, not a map of a planet or a country, but a map of a star system. It wasn't rendered in 2 or 3 dimensions, however. That was the mistake we had been making. The signal was broadcasting a set of coordinates that were fundamentally 4-dimensional. It was a schematic of space-time itself. It detailed the positions of several planets, their orbits, their approximate mass, all described as depressions in the fabric of space. We saw their sun, a G-type main sequence star, a cosmic cousin to our own. We saw a gas giant with an elaborate ring system. We saw 2 rocky terrestrial worlds orbiting within the habitable zone. We were looking at a portrait of another family of worlds rendered in the language of gravity. For days, the teams did nothing but stare at this celestial blueprint, rotating it on holographic displays. The emotional impact was staggering. This wasn't a theory. This wasn't a probability calculation. This was an address, a definitive, unambiguous declaration of existence. Our universe, which had felt so vast and so empty, suddenly felt intimate. We were no longer alone, and we knew with absolute certainty precisely where our neighbors lived. The star catalogued centuries ago as a faint flicker in the constellation of Cygnus now had a name, a personality, a family. It was no longer just a star, it was a destination. Yet it was the final detail of the map that truly and irrevocably altered our future. Among the planets, among the graceful, predictable curves of their orbits, there was something else. It was an anomaly in the space-time geometry, a feature that did not correspond to any mass. It was a line, a direct, impossibly straight pathway connecting 2 of the planets in the system. According to our understanding of physics, it was impossible. Mass bends space-time. It cannot create a perfectly flat, linear corridor through it. But the signal was unequivocal. It was broadcasting this feature with the same certainty as it broadcast the location of their sun. And this is where the Laniakea constant revealed its true purpose. It was not just a decryption key. It was the mathematical principle that times described times, this anomaly. The constant our teams realized was a ratio. It was the ratio between the energy required and the resulting geometric distortion of space-time. What we were looking at was not a natural phenomenon. It was technology. It was a stable, traversable wormhole, an Einstein-Rosen bridge held open between 2 worlds. It was a highway through space-time. The beings who sent this signal were not just masters of their solar system, they were masters of its very fabric. They did not travel times through time-space, they commanded it. Our most ambitious, most speculative theories of interstellar travel, the dreams of science fiction, were being presented to us as a solved equation, a demonstrated piece of engineering. This revelation rippled outwards from the core of Project Chimera and broke across the world like a tidal wave. Everything had changed. Our scientific paradigms, built up over centuries of painstaking observation, were shown to be tragically incomplete. General relativity wasn't wrong, but it was a single chapter in a much larger book. We had been trying to understand the cosmos by candlelight, and someone had just handed us the schematic for a star. The philosophical implications were even greater. We had discovered life, yes, but we had discovered a form of intelligence so advanced that it treated the fundamental forces of the universe as tools. The gap between us was not one of centuries or millennia. It was an epochal chasm, a difference so profound it forced a complete re-evaluation of humanity's place in the cosmos. We were not just one of 2 intelligent species in the galaxy. We were infants staring up at titans. This was not a conversation between equals. It was a lesson. a demonstration. The map, the primer, the impossible physics, it was all a preamble, an introduction designed to bring us up to speed, to give us the barest, most rudimentary context for what was to come next. And the signal, this magnificent, terrifying, beautiful signal, had not stopped. Having provided the dictionary and the map, it was now shifting again. A new layer of information was beginning to emerge, a layer we could now finally begin to read. The introduction was over. The real message was about to begin. Humanity, united and silent, held its breath and leaned in to listen. And so our odyssey comes full circle, returning to the profound silence that preceded the storm. We began with a single anomalous beat in the cosmic rhythm, a fleeting whisper that could have so easily been lost in the static of the void. It arrived unannounced, a ghost in the machine, a signal that defied every known celestial process and tore a hole in our comfortable solitude. You have journeyed with the scientists through their sleepless nights of disbelief, felt their pulse quicken with every new layer of impossible structure they uncovered within that pattern. You have stood with them on the precipice of a discovery so monumental it threatened to buckle the very foundations of human thought. We were a species that shouted questions into an apparently empty cathedral, and for the first time in our history, against all odds, that cathedral whispered something back. That whisper has now become the defining symphony of our age. The world before the pulse and the world after are two fundamentally different realities, separated by a line drawn not in the sand, but across the stars. Before our search for extraterrestrial intelligence was a matter of faith, a hopeful gamble played out on the fringes of mainstream science. It was a noble yet lonely vigil. Now that vigil has transformed into a global conversation. The question is no longer times, if times we are alone, but rather, what is the intricate meaning behind this first chapter of an interstellar dialogue we have just begun to comprehend? The discovery did more than just prove the existence of another intelligence. It validated the most persistent and audacious dream of our species. It affirmed that the yearning to connect, to reach out across the impossible darkness, is not a uniquely human trait, but a universal impulse woven into the fabric of consciousness itself, wherever it may arise. The impact on our science has been nothing short of a Copernican-scale revolution, a paradigm shift so deep and so absolute that textbooks written only a decade ago now read like ancient history. Entirely new fields of inquiry have blossomed from the fertile ground of this one discovery. Xenolinguistics, once a theoretical playground for science fiction authors, is now one of the most heavily funded and prestigious disciplines in academia, attracting the brightest minds in mathematics, anthropology, and computer science. They are the new archaeologists painstakingly excavating meaning from the dense, multi-layered data stream, treating each packet of information like a sacred artifact from a lost city. We have seen the birth of signal integrity physics, a discipline dedicated to understanding how such a complex message could traverse thousands of light years with its structure so perfectly preserved, a feat that suggests a mastery of space-time that still borders on magic to our finest thinkers. Our very understanding of information theory has been shattered and rebuilt as we grapple with a message that encodes data not just in its sequence, but in its very geometry, in the subtle fluctuations of its quantum state, and in the haunting recursive symmetries that echo across its length. But the echoes of the pulse have reverberated far beyond the sterile confines of our laboratories and observatories. It has permeated our culture, reshaping our art, our music, our philosophy, and our spiritual beliefs with an irresistible force. We see it in the soaring architecture of new buildings designed to mimic the intricate fractals found within the signal's core. We hear it in the compositions of musicians who have abandoned traditional scales, instead using harmonic frequencies translated from the pattern to create an entirely new, unearthly form of music that speaks to a primal part of the human spirit. Philosophers now debate not the meaning of life, but the meaning of times. Lives' times, grappling with the staggering implication that our entire story, our triumphs, our tragedies, our gods, our wars, is but a single, localized verse in a story, potentially infinite cosmic epic. Theologians from every faith have been forced into a profound re-examination of their scripture, searching for ways to reconcile ancient wisdom with the undeniable truth of another thinking presence in the universe. This signal did not destroy our faiths. For many, it expanded them, transforming the heavens from a mere ceiling into the roof of a shared and sacred cosmic home. It has even changed how we see ourselves. For a brief, incandescent moment in our history, the pulse dissolved our borders. When the first tentative translations were released, revealing not a threat, but what appeared to be a guide, a star map, a primer on fundamental physics, a complex biological blueprint, humanity instinctively came together. We were no longer defined by the flags we flew or the languages we spoke. We were simply Earth, the recipients of a message from the deep. The conflicts that had consumed us for millennia suddenly seemed so small, so tragically provincial when held against the backdrop of this galactic handshake. We learned that the ultimate solutions to our terrestrial problems of division and strife might not be found in treaties or negotiations, but in a shared upward gaze, in the humbling realization of our true context within the grand universal tapestry. The pulse became our cosmic anchor, a fixed point of shared wonder that stabilized our often turbulent world. Yet we must be honest with ourselves. For all the progress we have made, for all the breathtaking revelations you have witnessed, we stand as children before a library filled with books written in a language we can barely pronounce. We have translated the most accessible layers, the mathematics, the physics, the raw cartography of it all. These were the keys, the primer deliberately placed at the forefront of the message, a gesture of universal fellowship. But the deeper layers, the ones that hint at philosophy, at art, at a history spanning not thousands but perhaps millions of years, remain stubbornly opaque. They are a lock for which we have not yet forged the right key. The patterns are too complex, the logical structures too alien. It is a form of communication that seems to operate on principles our own minds have not yet evolved to grasp. We are like ancient humans staring at a microchip, able to appreciate its intricate design, but utterly incapable of understanding the flow of logic and electricity that gives it purpose. This profound mystery, however, is not a source of despair. It is a gift. It is the grand challenge that will define humanity for the next 1,000 years. Just as the great cathedrals of Europe took generations to build uniting communities in a common sacred purpose, the full deciphering of the pulse will become our multi-generational project. It is a legacy we will pass from parent to child, a scientific and intellectual relay race across the centuries. It ensures our future will not be one of complacency or stagnation. It provides us with a purpose worthy of a species that has learned to reach for the stars. We are no longer just explorers of space. We are students. We are apprentices to a silent, distant master, and our curriculum is written in the language of the cosmos itself. The responsibility is immense, a sacred trust placed upon us by the simple random act of our telescopes being pointed in the right direction at precisely the right time. And we are rising to meet that challenge with a fervor that would have been unimaginable just a generation ago. Our response has been to build a new generation of ears, instruments so sensitive and so powerful they make the observatories that first caught the pulse seem like primitive crystal radios. You are now seeing the first light of these new ventures, the dawn of an unprecedented age of listening. Deep within the perpetually shadowed Shackleton crater on the Moon, shielded from the ceaseless electronic chatter of Earth robotic construction crews, are assembling the Echo Array. It is a radio telescope not built of steel and wire, but etched directly into the lunar regolith, a dish 100 kilometers wide, capable of hearing the faintest whispers from the edge of the visible universe. It is our planetary ear turned forever toward the source of the signal, listening for the next transmission, the next lesson. Far beyond the orbit of Pluto, drifting in the silent cold of interstellar space, the scribe probes are being deployed. These are not tools of exploration but of patience. They are a network of gravitational wave detectors and quantum entanglement receivers designed to listen for messages encoded not in light but in the very fabric of space-time. This is a colossal gamble based on theoretical principles derived from the signal itself, an attempt to tune into a mode of communication we barely understand. We are reaching out with senses we have had to build from scratch. And on Earth, in the most remote deserts, and on the highest mountain peaks, vast new supercomputing facilities are being constructed. Their sole purpose is to house the artificial intelligences being developed to tackle the signal's unbreakable core, to simulate alien modes of thought, and to search for the hidden keys to its deepest secrets. This is the new space race, but it is a race not for dominance but for understanding. It is a global collaboration on a scale never seen before, a testament to what we can achieve when we are united by a shared sense of awe. This is our new reality. From a species that once huddled around fires telling stories about figures in the stars, we have become a species that listens to the stars for the next chapter in a story grander than any we could have ever conceived. We have been fundamentally and irrevocably changed. The knowledge that we are part of a living, breathing, thinking cosmos has infused our journey with a new and profound sense of meaning. Every child born today will grow up with the certainty that humanity is not the sole proprietor of intelligence, but a member of a galactic community whose other constituents we have not yet met. They will inherit not our old anxieties about solitude, but a new and thrilling anticipation of discovery. The future is no longer a straight line extending from our own past, but an open frontier of infinite possibilities, shaped by the knowledge that we are participating in a conversation that spans eons. So where does this leave us? At the end of this particular chapter of the story, we are left with a feeling of profound and beautiful incompletion. We have been given the opening paragraph of the greatest book ever written, and now we as a species have the humbling privilege and the monumental task of learning its language so we can read the rest. The silence of space has been broken forever, replaced by the tantalizing promise of infinite complexity. That first weird pattern in the pulse was not an answer, it was an invitation. An invitation to grow, to learn, to evolve, and to finally take our place as a mature intelligence in a universe far more crowded, far more mysterious, and far more wonderful than we ever dared to imagine. The universe continues to whisper its secrets, and for the first time, all of us together are truly listening.